All right. So hi, everyone. Welcome to the MuleSoft Study Group. This is IQ MuleSoft Study Group. Today, we have a special guest. His name's Francis Edwards. You may have seen him in the study groups or just around. And I'll talk more about Francis later. But the topic is going to be on decomposing and building MuleSoft functionality. So as far as the agenda, the introduction, which we're getting into, an upcoming workshop and meetup, as well as the main events, and then I'll close off with closing remarks. So it's a good time to level up on your skills. So IntegrationQuest is introducing their workshop series called Master MuleSoft Testing with MUnit. And it's going to be a series of workshops. The registration or the enrollment opens Sunday, January 28th. And the link below, I don't know if you guys can see it, but this link below is where you go to get on the wait list. But remember, January 28th. And what's really cool about this is not a MuleSoft event, but this is an IQ event. And the individuals that are going to be facilitating this are certified instructors. So you can get the best of both worlds. Next, today, Ryan is going to do a Cleveland meetup, and it's on secrets management. And I know you probably can't see fully the date, but it's today at 3 p.m. Eastern Standard Time. So to register for that event, you would go to meetups.mulesoft.com and search Cleveland. Okay. All right, now you're up.
Okay. Hi, I'm Francis Edwards, and I'd like to just start off by saying that those trainings are really useful. Since the last IQ meetup, I've done my platform architect and integration architect re-certifications and passed both of those. Couldn't have done it without the help of the training that I got from some of these guys. I've been working in MuleSoft for quite a number of years. I think I've been working for about 7, 8 years now. So I've been here through Mule 3.8, well, 3.7 even, onto the latest MuleSoft. So I'm going to be talking about everything I've learned in MuleSoft, how to decompose those functionality that in typical flow to get into something usable. So I'll share my screen for starters, and this is typically what I get shown. So this afternoon, I had one of my colleagues come to me and said, I'd like to build API-led MuleSoft integrations. I'd like to talk two systems, and I'd like it to be bidirectional. So this is what he thought he set out. He was quite new into MuleSoft, so he understood the concept of experience layer, process layer, and system APIs. He understood the concept of grouping things together. So he had a number of applications, like one experience here, one experience layer here, 4 process layers, and then 2 system layers. So far, so good. But that's going to give him 8 APIs, and he wasn't really sure how to begin, what sort of RAML to do, what sort of things to describe. He knew that he needed to post orders out of one system and put them into the other system, and post orders out of another system. So some of these things, like the shipments and delivery, we're going to take 2 different delivery types or 2 different shipment types. They would have different reference numbers, so different patterns on the delivery ID and the shipment ID. And he wasn't sure how these would handle and how to break his code down. So his real problem was he figured out, he wanted to ask, is this the right design? To which I replied, yes. But he wanted to know, how can he then implement the actual implementation, the code implementation? How do we go about doing this? So I took him through what I know about MuleSoft. So this is Studio. And typically back in the Mule 3 days, we wouldn't have API-led development. We would typically have one process flow that handled the experience layer right way through the system layer. You would get something like picking up a file. Invariably, you would do some logging, some transformation, some validation, and then be the process layer. You might want to choose which place it's going to. So based on the data input, you might want to go to one system or a different system. And then finally, you'd get a response back from that system, and you'd maybe do some validation or transformation just to get that to the, just to get a response back to the user or to log something. So how does this change? How does this change with API-led development? Well, that's what the next thing I had to explain to him. I said to him, when you have functionality in one flow, it's very hard to do things like unit testing. It's very hard to do error handling because your error handling has got to capture errors from so many different types. So the first thing you want to do is look at subflows or other private flows and break some code up. So instead of doing writes and reads within the same flow, you might want to move a write into a subflow. This is not making it so easy. You might want to move the writes into another flow and flow reference it. So that's what I've done here. I've created two flows. And the main flow now just has references to the other flows, and any error handling for these writes can be handled separately. So that's an example of how you can break up your flows, even within just one application, just so that you can get your error handling sorted out. These systems here, if they're two separate systems, it would make sense to put them into separate system layers. So I haven't stretched them across the system layer yet, but typically this flow would be the flow that you'd find in the process layer. These would be the flows that you'd find in the system layer, and two different system layers at that. Then when you look at system layers, what sort of things do you do? Well, if you're writing a message out, you might want to log some of the attributes beforehand, log some of the attributes afterwards. If it's a simple write, it might be things like the file size, the file length, what the file name is, and whether it's written back. If it's an API, you might want to record some of the response headers and some of the request headers going in, just to make sure that you haven't done something like SQL injection. Other things you might want to do on a system, and this is one of the exam questions you might get asked, is you don't want to overload the system. You might want to put spike control in. So that's the reason why I've got this idempotent message validator. So these things are things that can be put in implementations, but you might want to consider, do you need to have all the functionality within an implementation? Things like these idempotent message filter, that's very similar to something like a rate limiting or a spike control policy. So why not externalize that and put that into a separate policy? Your system layer could then just log your request and response headers. It could have the writing, whether it's a database connector, file, API connection, but then have the idempotency as a drop-in and drop-out policy. The same for the second system. So going back to the first process layer, you look at the process layer and you're thinking, what things are pretty standard within all flows? Well, you'll see that I've got a logger right at the beginning, and a lot of people typically use the logger at the beginning and end. But then you need to consider policies again. There's a standard message logging policy within MuleSoft that logs both messages at the beginning and the end of API calls, but it also logs in writing out and responses from outbound requests. So rather than putting loggers within all your flows, why not have that as an externalized policy? Why not just drop a policy onto your process layer and log the messages? That removes the need to have loggers within the flow and simplifies the flow further. You might want things like validation. Now, one of the things about API-led development is that validation is the reason why we invented the API kit router. So typically in an enterprise service bus point-to-point integration way, you would be doing things like picking up files. And for development purposes, I tend to have a file pickup as the main method of testing the flow. But when you scaffold a flow from RAML, you will start building the API kit router. And you can then route that output into the main process flow. And that's one thing to bear in mind. You can just have a file pickup for development purposes, but in the real world, you'll probably feed the data in through an API and set up RAML. Now, so that people are aware of what the RAML kit router is, I've just outlined this flow just to show exactly what it does. It'll pick up data from a HTTP listener. It'll then validate the data. So the RAML specification will validate what data is coming in, any regular expression patterns, any schemas, before it then captures some of the variables. With RAML, you can have things like URI parameters. You can have things like the query parameters in the headers. All those things are captured along with the schema being validated from the input, either JSON or XML. And then based on the query string, you choose which route to send it to, and the route is usually back to the process flow. So this, in effect, is what is happening within the API kit router. You might not. So when I make a flow, whether it's a process layer, experience layer, I typically have all my process functionality in a line. I consider which elements I need and take them out where necessary, and try and do as much possible within the API kit router by doing things like the RAML definition, defining the input types. The input types are really useful to be put in with an HTTP listener, because you can prove the validation in RAML, and you can reuse some of that data types when you're looking at other things. So another way of inputting data into your flow might be with a queue. So one thing I want people to realize is that you don't have to consider API-led to just be feeding data in with HTTP listeners. HTTP listener was just the step up from picking up things from files or SFTPs. MQs is another way of reliably picking up data, or you could pick up with HTTP and post into a queue for reliable pickup. But if you had a process layer and you wanted to pick up from a queue, you would want to do the same steps that the API kit router do. You'd want to validate the schema. You'd also want to capture some of the variables. One thing that we know about queues is that they keep metadata attributes, but they're not the same as HTTP headers. So you might want to capture what attributes you can, or default properties, so that you can have something that's similar to HTTP headers and HTTP request and response headers. Then you'd use a flow reference, just like a choice router, to go back into the process flow. So when I'm making any sort of functionality, that's what I'm looking at doing. I'm not looking at just confining myself to one type of input. I will typically start with a file input based on something that I can draft up quickly. I will then draw up the RAML and describe the data objects going in, have a listener, validate it within that router and post it into the flow, and then look at the requirements to see how we're connecting things together. So going back to the diagram that I was showing this afternoon, I was told that this system, the experience layers, would typically be picking up from files, so SFTP file endpoints, and then the process layers would like to pick up from queues. So this API, I would still make a HTTP listener. I would still allow the test data to be put into the HTTP listener, and that would be used for integration tests. But essentially, I'm going to pick up from a file location, do the same steps, and then post into a queue. For the process layers, I'm going to do the same process. I'm going to have the flow doing the work that it needs to, whether it's using a choice route to go to a system based on a validation of a field. But I'll also put a HTTP method, because at some point in the future, that HTTP listener might be used for a different posting data in. These experience layers into SAP, for example, will be picking up data from OData tables, and they will be able to post data out with a HTTP requester. So the process layer is going to need a HTTP listener anyway, just to take data from here, even if it is a queue, take it from here. So that's what I explained with how to set up the different inputs, have them in separate flows, because then you're limiting what needs to be done within each flow, and you're limiting the functionality to one discrete type of functionality, and the error handling is then made more simple and not conflicting with the other parts. Only reusable code. So these are the different methods of pickup, whether it's by MQ, whether it's by SFTP, doing the same steps. Each one will have the same output at the end, ideally a JSON object that can then be fed into the main flow. So that's how I would break down a flow to limit what I see and to allow different connections between the API-led structure. The policies parts that I mentioned about, one thing that I've seen a lot of people talking about on Slack channels and within the Mule forums is people say, you've got an API kit router that does a validation on the way in, but do you validate data on the way out? Now, there's no policy to do a validation on the way out, but you could add a validator into the end of your flows, but then it would probably be unique within each implementation, whether it's process layer, system layer, experience layer, for example. So why not think of this component as being something you can drop in the same way as you can drop in a message logger via a policy? in the same way as you can do some transformation within a policy. So things like changing the attribute keys to camel case, for example, or masking some of the payload outputs. You could also have a validation. So think of how you can create a policy that would do a validation based on a JSON schema. And this is one of the reasons why when I'm creating RAML, I tend to use JSON schemas to be the way I do, validate data, whether it's on the input or the output side, because this makes it more usable across the different APIs, because it's likely that the data elements are going to be very similar in that API-led structure. So that's really all. If anyone's got any questions, do write them in the chat and get Whitney to coach them to me. Nope, I'm going to assume that was.
Sounds like Whitney's baby has a question.
Yeah.
Yeah, I had a question.
Well,
Baby's in the background though. So when you're using, okay, so inbound, you're using a policy, and outbound, you're using the validator that's in MuleSoft.
Well, I can use a policy. This is what I'm getting at. Think about how you structure flows. A lot of people have loggers on the end and beginning. A lot of people have validators on the end and beginning. A lot of people have, well, I have thought of lots of transforms to have on the end. So within my Exchange, I've created a number of policies. These are custom policies that I think I've mentioned in other meetups, but you can go hunting in the Exchange, in the Catalyst, and you can find things like the canary policy, or you can find things like the which ones, circuit breaker. So I picked up from the knowledge hub, the Catalyst, the canary, the circuit breaker, the exponential retry, and I think the client enforcement policies. But the other ones I thought of myself to either put at the beginning or an end of a flow. So things like masking values. Think about PII data. You've got an API, you're putting data in, you're getting response back. You might not want to show things like client secrets or passwords or address or telephone number fields. So this is a policy that I've created. In a sense, it's just the transform. It's just a transform message component that you drop in at the end of an API call. It looks at the output, and at the moment it only supports JSON, but it looks at the JSON output. It'll use the data we've passed through the attribute keys, looking for an array of strings that you input into this policy. So it's looking for password, it's looking for client secret, and then it'll mask the payload of those keys. So that's a piece of functionality that you could implement in something like an experience layer, but wouldn't it be better to have it as a policy so you could drop it into any experience layer, or indeed into some system layers if you are feeding systems where you didn't want to send them PII data. Think, for example, logging. Some of the other policies that I thought of were the standardized keys. You might get an output from a system, and think of the attribute keys. They might be in camel case, they might be in kebab case, they might be in title case. You might have a mix of cases. You can use DataWeave again to go through the keys, list them, and change the case. And that's what I've done. I've just got one DataWeave element. It used to exist in one application, but I've extrapolated that, saved it into a policy. But this policy can now be applied to many different APIs. So for example, I could apply it to an experience layer. And that's one thing you have to think of with the difference between process layers and experience layers. Process layers can pick up a full data object and have a number of resource types that it can handle, and a lot of different methods that it can handle. But an experience layer doesn't have to be a Mule implementation. You can set it up as a proxy. If you write the RAML specification for experience layer and you do a subset. So for example, if we go into example one that I did, you might have process layer where the RAML specification is for one resource, and then you might have a second resource, if I could spell resource, and you might have a get and a post. So that may be the RAML for like a process layer. access to two different resources, you can have a number of different methods. When you create an experience layer, you can just define almost exactly the same as the process layer, but just remove what you want. So you might not want a post or a delete, for example, possible in the experience layer. So all you have to do is either comment them out or remove those methods, and that acts as like filtering. So if you create an API proxy with a filtered version of the RAML specification, your experience layer won't be able to access the post and the delete method from the process layer. But the great thing about having experience layer as an API proxy is you can still apply policies. So we can think of policies that we can apply that are simple data weaves. You might want something like a filter, for example. There is things like idempotent filters. So you might want to filter on a certain field within your input type. You might look for a regular expression pattern and say, I'm only going to allow orders that have this order type because then I know it's from this system, for example. So this is what I was explaining to my colleague. When creating your system layers and picking data up from a system and feeding the process layer, you don't have to do a MuleSoft implementation and use a vCore and then write code. You could just simply define it in RAML. It could be a subset of the RAML that you've already defined for your process layers, set up an API proxy and apply policies to it. Because typically an experience layer is going to look after things like security. So you can add an OAuth to policy. It's going to look at things like filtering. So you could make a filter that acts before the API looking for elements within the payload. They could either drop or send messages through. You can look at things like some validation. You can look at some things like spike control. You can look at things like masking data, for example, before it passes into the process layer. So that's something to bear in mind when you're trying to write these eight APIs. Where do you want to put your effort? Which needs to be done the first and which can give you the quickest results. And that's the reason why within Studio, I showed you a flow that would literally pick up from one end and drop it off at the other end. But then that's mostly going to be in the process layer. So when I start an integration like this, I tend to start with process layers first.
We have Mule.
Yep, go and ask away. Was that a question I had?
If it wasn't a question, can you mute yourself?
Okay, not to
Hey, Francis. Hey, Francis, I have a question. This is Jesus.
Yes,
How are you? How are you, Francis?
good, thank you.
Thank you. Thank you. Hey, you were talking about the queues on the process layer, just in the presentation. I wanted to know a little bit more about it. If you can explain some of the advantages to have queues over there in the process layer.
The main use for queues is having, I think I've just demonstrated it here, is having reliable pickup. So you could yeah, that's what there are a few too small. Okay, that's the best way. That's probably the best way of describing it. Within the experience layer, you might want to have an API listener that listens for receiving JSON objects and then publish it straight into a queue. Once it's in a queue, you've reliably picked it up. You can return a 201 response. That's really one of the main advantages of the queues. So going back to this model, if you're getting events out of an SAP system, for example, you might want to post, rather than posting to a process layer, which might not respond in time, might be overloaded, you might have the wrong results, you might fail validation. I mentioned about having things like idempotent filters. I mentioned about things like having validation filters. So one of the easiest things to do if you aren't having a proxy and you are having an implementation is this sort of sense where you receive a message. You might want to add things to the message, because when you receive a message in JSON, you'll get a payload, typically a JSON payload, but then attached to it, you'll have metadata, the HTTP headers. Now, queues don't store HTTP headers. They store attributes, which are a bit like the metadata, but you may need to transform your request headers into attributes for publishing into the queue, so that when you take data from the queue, you can reform those HTTP headers. Some of the headers may be like irrelevant, like the client ID and secret, but others may be more pertinent, like which environment it's supposed to be going to, or what sort of payload it is, or what sort of MIME type it is. So it's important to realize that you'll get a lot of HTTP headers when you receive data from in a HTTP listener, but you need to convert these into the metadata that's attached to the JSON payload that's stored within the queues. Once it's stored within the queue, then your process layer can pick up from the queue. So going back to this model, one of these process layers could pick up from a queue and handle in its own time with less chance of API failure between the two. So if this was a HTTP request to go to a HTTP listener, you could have network problems. You could have proxy problems if the experience layer is outside your network and your process layer is inside your network, for example. So if you had a mixed environment, Cloud Hub and on-premise, it's possible that you could have network errors, firewall issues, IP whitelisting sort out. By posting into a queue and picking up from a queue, you're reducing the latency between receiving and storing into a queue, and you're making it more robust in terms of picking up from a queue as and when you need to, and you won't lose the data if you can't get it.
Oh, perfect. Okay. Yeah. Sounds good. Yeah, thank you. Very clear.
Good. So yeah, that's the only gotcha that I found with queues, that you do have to think about what attributes to add to the queues. So typically you'll lose things like correlation ID. So the API kit router, I mentioned that this API kit router, one of the great things about it is that it does all these things. It validates the schema, it sets some variables based on the URI and stuff like that. Other things it does is automatically create a correlation ID. That's not something you automatically get with a queue. So when you are picking up from a queue, you might want to do the same thing, set a correlation ID, or if one doesn't exist, so yeah, default create one, just like the API kit router does, or have one as metadata when it's published.
Perfect. Okay,
So
thank you.
I think of the headers that I've also used. I've used headers within queues. I've used headers, things like retries. If you're picking up data from a queue, you might want to try it once, a second time, but each time you write it back to the queue, rather than just picking up something from the queue, failing to process it and letting it drop in, you might want to add extra data. So I tend to pick up from a queue, try and handle it. That means validate it. That means check if it can go to the outbound location, validate it, enrich it, all the things that you might do within the process layer. If it's unsuccessful, I will add a new attribute called retry and give it a counter. So set it once, send it back to the queue. I might try it 3 times before then writing out. By having that retry, you're not just relying on the default dead letter queue behavior, you're actually adding some metadata. So if it's been through an enrichment step, you can probably say it's a retry, but it only failed at certain points. So you can add some extra metadata other than the typical correlation ID, other than the typical what sort of MIME type and payload consists of.
Yeah,
Does that help?
definitely. And making more robust the system for sure. Okay, good. Yeah, thank you.
Okay. So yeah, I was showing you policies, just give you an idea of what policies. Yeah, we're on this bit. So did everyone understand how RAML can be act as a filter? So you could have a fully described RAML with lots of different methods within the process layer that only make a subset available at the experience layer, and that mitigates the need to have to write the whole implementation. Was that clear for everyone? I'm going to assume that's a yes, and I'll go back to the policies to give people ideas of policies. So I was showing you the policies that I'd created, and I was saying that I'm still going to create a new one called validation. So do outbound validation. I rely on API kit to do inbound validation. I'm going to probably write a new policy to do outbound validation. But some of the other policies that I've created, I mentioned standardized keys was a useful bit of functionality. Another bit of functionality that stops you having to write it in implementation is doing service unavailable. So a bit like the circuit breaker, trying to stop inbound requests. I've got I can set this policy to take inbound requests and then return an immediate 503 response to say the service is unavailable. I've also done things like contention response. That's a good one. When you're testing APIs, you might want to you might want to handle something like a 429 response. So one of the things that Mule 4 introduced was back pressure. So if you try and overload an API, it will automatically give you a 429 response to say there's no thread available. It won't necessarily say that there's no thread available. What it will say though is here's a 429 response. So I wanted a policy that I could drop on top of system layers or process layers to do exactly that. It's typically for system layers. So rather than putting a handling into the system layer to try and make it be slow, so doing silly things like adding sleeps into the code just for testing purposes, this policy allows me to add either a sleep or an immediate 429 response. And that helps me handle in the process layer what I'd expect if I get a delayed response or if I get a 429 response. So that's what this policy is doing. It gives me an option of, do I want an immediate 429 or do I want to choose a wait? And then it gives me a default number of seconds for the wait. And I can set it to something like 11 seconds, which is outside the normal 10-second wait for a HTTP requester. And then that allows me to capture the error within my process layer that's being returned from a good system layer, just so that I know how it'll handle it under load. And that beats like within unit testing, for example, they say you can mock responses from external systems, but then have to figure out how to work out performance load within your process layer. But by having a policy that adds the wait for me, I'm not adding that into the code itself. I'm just using the policy to simulate high demand. The other ones, this is for security. Canary response is about choosing two different APIs. So if you have in this scenario where you have feeds coming in from two different systems and need to go out to two different systems, it might be that you're trying to direct traffic to mostly to one system and not to another. You could use a circuit breaker in here and say don't go to one, or you could use a canary policy that takes the input and sends it to another system. And that's essentially what I use the canary policy for. It doesn't act like an API kit router, so it won't do validation and it won't capture URIs, but it will capture response request headers. So long as I put things in the request header, like I would like this to go to one system or I'd like this to go to another system, that's what the canary deployment's really doing. It's taking data in, and based on request headers, it's choosing which direction to send it to. It's useful for things like moving from version 1 and version 2 of an API. So I can either predetermine, I can either have no request headers and say, right, based on a policy, I'd like to wait 5% of the traffic to the new V2, or even 100% when I'm ready to decommission V1. Other times I can use request headers and say, right, this needs to go to a particular test environment, this needs to go to a different test environment. And that's what this canary policy is doing. It's allowing me to redirect backend traffic based on the request headers and based on how I would like the default behavior to be. So the point of this talk and decomposing flows is just to explain that you don't have to put all functionality within one big flow. You need to consider what functionality is repetitive at the beginning and end. You need to consider what piece of functionality is useful for a number of different APIs, and extrapolate that out and put that into things like policies. So when I'm helping this new guy in my company design this system, my first statements to him are: concentrate on your process layers, design your data, and get your YAML specifications up. Even if you think you're going to connect these with message queues, you might want to validate the data based on some of the YAML definitions of your data types. So still have HTTP inbound ways of testing the data, because then you can have HTTP all the way through, but then you can switch to using queues once you're satisfied that HTTP testing. So JSON objects in, JSON objects out via HTTP is it proven to work. You can switch across to the other mechanism, whether that's SFTP in this case or queues in this case. And then think ahead and think what policies can you have that you can drop into each of the different APIs, because why create the code and test it in 4 different environments when you can create one reusable bit of code and apply it as a policy? And I suppose the final thing to say is with the system layers, treat them more like products. So treat them like as though they have an API lifecycle where you don't just have a post method. This diagram really does suggest that all they want is post methods. So my next bit of advice to him was, with these systems, think about, is there a way of getting data? Is there another database table that exposed where you could use a database connect to simulate a GET request and find out if your posted order had been retrieved? Is there a way of doing a webhook? So treat this system layer as something that's going to be pretty crucial for other systems to use. Don't just treat it as a gateway to put data in, otherwise you'll probably end up with duplicates, which he said, to be fair, is what's happening. So it's important that even if you think your system layer is just handling a post, try and get it so that you can do a GET. That could include things like setting up an object store and posting an order in, sending a 201 response, keeping a copy of that data, and then somehow in some other asynchronous way find out if the data has been updated, if an order has been created, tie it together in the object store, and then at least you know that a second order coming in is already, you can cross-reference against the data that's in your object store and make sure that a duplicate isn't created. I find that things like having an object store that's valid for a day just stops any duplicate orders within the same day, which is when it's the most likely time that it's going to happen. So treat system layers like a product. Treat it as though you might only have a requirement now to do a post, but really it would be great if you had the get, delete, and put capabilities added to it, because that's what makes it reusable to future requirements. So in summary, your process layers were what MuleSoft used to be all about back in Mule 3 days. We moved to API-led development, which means expose things as HTTP listeners and make it RESTful and define the GRAML, because that's what helps with things like the validation and the choice routes. But bear in mind that you can have multiple ways of ingress into each of the APIs. Your first focus really should be these process layers. Experience layers can be subsets of the process layers, especially if they're using the same data structures and not trying to do the transformations. But remember, experience layers are all about filtering, security, quality of service, and having different clients for different end users. So they don't need to be complicated. They can be API proxies where you apply policies, and where possible, do exactly that. And then system layers, when you're creating those, try and think of them as something that's going to be a long-lasting product and have a backlog, and think of the extra things that you'll need to produce. So that's in summary what I was going to cover in this decomposing flows. Does anyone have any other questions or any other requirements? Would they like me to answer some of their technical questions or architectural type questions?
So Francis, I think this was great, is great. And it gives me a lot to think about. So when you're having these conversations with different team members, are you having them throughout the entire project's life cycle, or just at the very beginning?
I am across the whole project life cycle. I put my hat on as the platform architect, which is where I talk about having like extra assets like policies, because if I can make code reusable, I can then include it in other projects. So as a platform architect, I suppose I touch on a lot of different projects, certainly at the beginning. I look at things like commonalities of user access requirements, or things like the OAuth 2, for example. I had to set up an OAuth 2 implementation, use the MuleSoft OAuth 2 provider to provide OAuth dance for our APIs that were hosted in Cloud Hub. So as a platform architect, I think of assets to build up a reusable library. As integration architect, I will touch at the beginning and help structure things. Then as a developer and code reviewer, which is where my level 2 development skills come into play, that's when I'm thinking about how can these be extended. Going back to what I said about the process layers and fully describing them, you'll find that in effect also helps you fully describe the system layers. So all the extra methods, all the different extra data types, you might want to handle XML as well as JSON, for example. You might want to handle different methods. All that's fed by what are the capabilities of the process layers, or what's the likely use of the process layer. Because remember, process layers originally were pick up something, send it somewhere, enterprise service bus. But then we think of process layers as helping us disassociate systems. So one of the key things that process layer will do is move us from version 1 of a system to version 2, or move us from one type of system to a different type of system. So those are the customers for the system layers, and that's why you really have to have regular architecture review boards where you review what the requirements of the different systems.
Makes sense. Makes sense. Any other questions? Okay, anything else, Francis?
No, that's probably all I wanted to cover today. A very high-level architectural focus, but then actually getting you understanding what it looks like within code.
Yes, yes. Thank you. Thank you. And if you guys can do me a favor and give Francis a reaction on your screen, there's a little emoji that says reactions with a plus sign. And I'm going to give him a thank you. Thank you guys very much. And then I am going to share my screen. So let me make sure I get everything right real quick. Give me a brief second. I don't know how the MuleSoft trainers do it with the Zoom. They do it without a hitch. But all right. So sharing the screen, and everybody should see my screen.
Yep.
All right. So
Yes.
great. Thank you. So the next event, guys, thank you again for attending. We know that this was super technical, but it was a technical gem that you would otherwise see at a MuleSoft event. But you're getting this here at IntegrationQuest, and it's in an environment where you can ask questions and not feel ashamed of it. Our next event is going to be February 9th at 12 p.m. But as you notice, we don't have an event subject. So if you have any ideas for what you would like to see next, please put it in the chat. We're also going to have a feedback form for speakers, because we really do want to have speakers and we value the expertise of our IQ seekers. That's what we call you guys, seekers. But we value your expertise. You have a lot to bring to the table. You contribute a lot to the MuleSoft community, and we're hoping that you can help us contribute more. All right. And then tell your Muley colleagues, your friends, your leadership's teams about IntegrationQuest and get the word out, because we are moving at full speed and we have a lot of good things coming. And since we have time, I just want to talk about this again. On January 28th, we're opening enrollment to the MuleSoft, the Mastering MuleSoft Testing with MUnit class. MUnit is something that is not really covered. And so, but it's so crucial to your integration careers as MuleSoft developers and architects. So you definitely want to enroll in this. The link below is our website /MUnit-workshop-2024. And this is where you can get on the wait list, and then you'll get a notification when enrollment starts. But I'm telling you right now, enrollment starts January 28th. If you are interested in MuleSoft Secrets and MuleSoft Secrets Management, that's going to be today at 3 p.m. Eastern Standard Time for Cleveland meetup, and the speaker is our very own Ryan Haig. I think that's it. Victoria, is there anything else that I'm missing?
Not that I can think of. I just hope everyone signs up to the Immunit class.
Okay, yes, place the link in the chat for the workshop, Ron. Let me get the link for you.
Thank you.
All right, so I'm gonna stop sharing and I'm gonna post the link in the chat. 1 second.
And thank you again, Francis, for your time today. I really appreciate it.
Problem?
Yeah, thanks a lot.
Thank you, Francis. That
It
was
was a-
great
It was a
presentation.
gem, really. Let's see. All right, I'm posting this in the chat now. And do you want me to post the meetup too? Hold on, let me just do that too. 1 second. It's in the chat. Okay, and then I can stop recording now.